Mechanical cultivation is the key practice for controlling weeds in organic vegetable production systems. Using standard cultivation methods, weeds can be quickly and efficiently removed from 80% or more of the bed top. However, standard cultivation also leaves an uncultivated band around the seed line. Any weeds that remain in this uncultivated band are typically removed by hand. If weed pressure is high, hand weeding costs can be a substantial part of the crop production budget. This video discusses several available weed control tools that remove weeds from the seed line and make subsequent hand weeding operations more economical and efficient. There are now commercially available machines that use computers to guide weed control implements. One example is the Tillet Weeder from the Garford Company in England. It uses a camera and an image processing computer to distinguish weeds from crop plants. Rotating notched disc blades remove weeds from the seed line. The guidance system detects crop plants and tells the blade to rotate around them. This machine works best with transplanted crops which have a large size differential between the crop and the weeds. Another example is a thinner weeder developed by the University of Arizona and Mule Deer Engineering. It precisely sprays herbicides to kill unwanted plants in the seed line. Organic herbicides can be used with this machine. Another weed control tool is the use of blind cultivators. Blind cultivators do not rely on a guidance system, but rather take advantage of the size difference between transplanted crops and small recently germinated weeds. Two examples we will discuss here are torsion and finger weeders. Torsion weeders were originally developed by Bezerides brothers in California, but are now sold by the Fredo Company in the Netherlands. It is a spring steel rod that runs below the soil surface, undercutting small weed seedlings. Firmly rooted transplants are less affected by the implement because the oblique angle of the rod allows it to bend around the transplant. Finger weeders were originally developed by the Budding Company in Michigan, and a modified design is now marketed by 3 European manufacturers. The finger weeders shown here were manufactured by the Crest Company in Germany. They are designed for use on transplanted or large seeded vegetables. They are made of plastic and come in different sizes and levels of hardness. Like the torsion weeder, the fingers can be adjusted to hit against the transplant, but will flex around them. As the fingers move through the soil, they uproot young weed seedlings. For both torsion and finger weeders, the timing of cultivation is critical. For transplanted vegetables, cultivation should be done after the transplants are firmly rooted, but while weed seedlings are still in the white thread stage, which is typically 10 to 14 days after transplanting. Care must be taken to adjust the aggressiveness of these implements so that they do not cause damage to the transplant by breaking small feeder roots. In our studies, lettuce was more sensitive than broccoli or leeks. Trials were conducted on commercial vegetable farms on the central coast of California to evaluate the finger weeder's ability to remove weeds and their safety on transplanted vegetables. In a trial on organic leeks, the uncultivated band left by a traditional cultivator can be compared to the seed line on the right, which was cultivated by finger weeders. Here you can see the weeds left behind in the seed line after standard cultivation. Finger weeders removed 80% of weeds compared to 29% for standard cultivation methods. Hand weeding time was reduced by 45% compared to standard cultivation methods. The yield of the leeks was not affected by the finger weeder cultivation. In a trial on organic radicchio, the finger weeders removed 81% of weeds compared to 48% of standard cultivation methods. Hand weeding time was reduced by 44% compared to standard cultivation methods. The yield of radicchio was not affected by the finger weeder cultivation. In 6 out of 8 trials, finger weeders significantly reduced weeding time compared to standard cultivation. Weed species that were controlled with finger weeders included burning nettle, pigweed, groundsel, and purslane. Little mallow was more difficult to control because it emerges rapidly and has a resistant taproot that is difficult to dislodge. Soil moisture also influences the effectiveness of the finger weeders. Soil that is too wet or too dry will reduce the effectiveness of the weeder. Once cultivated, it is best to allow for a dry period so that the unearthed weed seedlings dry out. Our research has demonstrated that the finger weeder can be an effective tool for removing weeds in the seed line. They are not a replacement for hand weeding, but make hand weeding operations more efficient and economical, thus reducing costs relative to standard cultivation.